So what is Arduino? Imagine a tiny, affordable microcontroller with its own software that you can program to control just about anything. Lights, motors, sensors, and so much more. Basically, it's a customizable computer to bring your ideas to life. Whether you want to build a robot, automate your desk, or just learn electronics, Arduino is where most people start. It's perfect for beginners because you don't need any prior experience. You can just plug it into your computer, write simple code, and upload it. I'm going to walk you through everything you need to get started. First things first, let's go to the official website and install the Arduino IDE. This is where we'll write all of our code. Select your operating system, click download, and there you go. It's that simple. Go into File Explorer and walk through the setup process. Once you're finished, you should see this open up. This is the IDE, where we're going to write all of our code. But first, let's take a look at an Arduino Uno. This is most likely the board that you have, the Uno R3. These are digital pins, which can read and output a signal as on or off, in other words 0 or 5 volts. These analog pins can read a signal that varies between 0 to 5 volts. This is a 5mm LED. The shorter pin is the negative terminal, which will be connected to ground, or 0 volts. The longer pin is the positive terminal. There's just one problem. If we connect the positive end of the LED to the digital output on the Arduino, which is 5 volts, it will burn out. So, we need to use a resistor, which limits the current flowing through the LED, so it doesn't burn out. To calculate what resistor we need to look at 3 things. 1. The forward voltage on the LED. This varies by color, and you can search it up, but it's usually around 2 volts. The source voltage, this is 5 volts coming from the Arduino's digital output. And then the LED's operating current. This is usually around 15 milliamps, but once again, you can search this up. Now, we can use Ohm's law to find out which resistor we need to power our LED. This is V equals I times R, where voltage is the difference in electricity between 2 points in a circuit, like pressure in a pipe. To find this, we subtract the LED's forward voltage, which is around 2 volts, from the source voltage, which is 5 volts from the Arduino's digital output. Current, represented by I, measures how much electricity is flowing in amps. This is 15 milliamps for our LED, or 0.015 amps. Resistance is measured in ohms, represented by R. It's like friction in a circuit that slows down the current. If we rearrange for R, we get 200 ohms. The most common resistor closest to that value is 220 ohms, which you probably have. It looks like this. If you have a 150 ohm resistor, those would work best for red LEDs because they have a lower forward voltage. As mentioned before, each LED has a different forward voltage, and you can use a different resistor if you have it to get a better output. This is a breadboard, and anything you plug in will interconnect via the vertical lines. So here's the Arduino. We're going to connect a jumper cable to digital pin number 4. Then attach the other side to the breadboard. From here, we're going to take the 220 ohm resistor and attach one side so it connects to one side of the jumper cable. And now we're going to take our LED and the longer side, which is the positive terminal, we're going to connect to the other side of the resistor. Now, take another jumper cable and connect the other side of the LED to any pin on the Arduino that says ground. Alright, you're good to go. We can start coding now. We're back in the IDE and we're going to write some simple code to make our LED blink. In the void setup, the code we write will run once. So, let's initialize the digital output. So we chose pin number 4. This is a parameter that we input, and then we need to specify whether it's an output or input. Then, since this is C++, for syntax, we just have to write a semicolon to signify that we ended the line. Now, in our loop, first thing we want to do is turn on the LED. The function to control a digital output is digital write. We specify our pin, and then high or low. High being 5 volts, low being 0 volts. Semicolon. Now, we want this to be on for a certain amount of time. If we don't write anything after this, it's going to be on for a split second. You won't be able to see it. So we're going to give it a delay, and this is in thousandths of a second. So let's say we want it to be on for half a second. Input 500, semicolon. Now we want to turn it back off. Specify the pin, and low being 0 volts, nothing. So if we don't write a delay after this, it's just going to turn off for a split second again and come back on. So we need a delay, and we'll say half a second again. So this is going to loop on forever, and we have a simple blinking LED. Plug in your board to your computer, select Tools, select the board that you have, Arduino Uno, or Nano if you have it, and then here you should see your Arduino pop up once it's connected. From there you could click the upload button, and you're all set. You should see a blinking LED. Comment down below what tutorial I should do next, and any questions you might have.